So we're going to start chapter 7. In chapter 7, one of the main things we're going to be doing is solving systems of equations. Well, the good news is you've already done this in other math classes. If you remember, a system of linear equations is just a set of equations. And if they say linear, that just means they're lines. The goal is to find where those graphs are going to cross or where they intersect. And that intersection is called the solution of the system. Okay, you are always going to write that solution as a coordinate or an ordered pair because it is a point where they cross. So we've got three kinds of solutions. You could have one where there's an actual point that they cross, and that would have one solution. You could have two lines that never cross and they're parallel. So parallel lines never cross. So there would be no, the number of solutions is going to be none. That would be a no solution problem. Then you could have two lines that were actually the exact same line. In that case, you have an infinite number. All those points are going to be a solution. A lot of textbooks go into great detail defining whether these systems are consistent, inconsistent, dependent, or independent. That is something I will never ask you. You may need it for your homework, but I'm never going to ask you that. Okay, so we have several methods of solving systems of equations. There's 5 right here: graphing, substitution, elimination. Those first 3 are what we are going to be doing in this section. Those are also the 3 that you have done before. Notice the other 2 are calculator methods. So a lot of this chapter is going to be just learning how to use your calculator. Okay, so let's look at the first one. Solve by graphing. So basically you're going to look at example number 1 down here. You're going to take each one of these lines and you're going to graph them. Then you're going to find out where they cross. So the very first one, it's not written in, I call it graphing form. It's not written so that it's ready to graph. So we're going to change it. We're going to take and we're going to move that x on the other side. So we get x plus 3, y equals x plus 3. So that my slope is going to be 1. I usually write it as a fraction, rise over run. My y-intercept, some people call that b, is 3. Let me go ahead and graph that. So I'm going to start at 3. Remember, you always are going to start on your y-axis, okay? So you start at 3, and then my slope is positive, so I'm going to go up 1, and then I'm going to go right 1. Up 1 and right 1. Now, I don't actually graph the line. I just do a bunch of points because I'm trying to see where these guys cross. I'm going to go back and graph the line in just a second. All right, let's do the next one. Again, this is not written so that it's easy to graph. So I'm going to move my x over, get negative x minus 1. So my slope is going to be negative 1 over 1. And my y-intercept where I start is going to be negative 1. So I'm going to start at negative 1. And this time I go down 1 and then right 1. Notice that's not getting me closer to the blue line. So I'm going to come up this way. There we go. There's the point where they cross. So now I go ahead and graph. I'm going to finish graphing the lines now. Now that I know where they cross. I'm really bad at drawing lines, as you can see. All right, so my solution is that point right there, which is the point, what, negative 2, positive 1. So my solution, negative 2, 1. Okay, now, like I said, we have 5 different methods. So I thought it would be good for us to determine when is it best to use graphing. So when should you use graphing? If you are graphing by hand, never. I never use that method, okay? The reason that I want you to know how to do it by graphing is so that you realize why you have these 3 kinds of solutions, okay? But also, you will use it if you're using a calculator. So never accept on your calculator. All right. So I'm not going to do another example of that. Let's go on to substitution. Again, you've probably used substitution before in Math 102. So we are going to solve for a variable, but luckily in example number 2, see, we already have it solved for a variable, y equals something. So I'm going to take this something right there, and I'm going to plug it right where my y is. So I'll have, let's see, 2x plus 5 times whatever y is -8. So I'm going to plug in that 4x minus 6 right there. So let's go ahead and solve that using stuff that I learned in, that's 30, not 20, using stuff that I have learned in Math 101. All right, so I've got 22x minus 30 is -8. If I move that 30 over, look, I get 22. When I divide, I'm going to get 1. So I have a lot of students that'll say x equals 1 and they move on. But you see why we have a problem with that? What do we say your answers had to be? They needed to look like this one right here, right? So I really only have done half the problem. I figured out what x is, but I need to know what my y is as well. So I've done this part, but I still have one more to do. So I'm going to take that x value that I have, and I'm going to plug it back into that first equation. That's what it says when it says back substitute the known value. That's what we're talking about. I now know that my x value is 1, so I'll stick a 1 in there. So that gives me what? -2, 4 minus 6. So my solution is the point 1, -2. Let's do one more. Number 2 was a little bit easier because we did not have to do step number 1. It was already done for us, right? We already had a variable all by itself. Well, in example number 3, we don't, but we're almost there. We've got to determine which one of these would be the easiest to solve for a letter. I've had students that choose the top one and divide by 3, and they're like, oh, I solved really quickly, but then you wind up with a fraction, 5/3. So I don't want to be plugging in fractions. So my first step, I'm going to solve for my y here. Y equals -x plus 2, or I'm just going to write 2 minus x because I think that might be easier. All right, so that was step number 1. Now I'm going to take that right here, 2 minus x. Oh, that's sort of hard to see. Sorry. I'm going to take that 2 minus x, and I'm going to plug it back into this one where the y is. So I'll have 3 times something is 5x plus 6, and that something is my 2 minus x. And then I just solve it, right? So that's my second step. Substitute into the other equation and then solve it. When you solve it, so this is 2 and 3. When you solve it, you should get a number. You should not get, an x. So I'm going to have, let's move my x on the other side. So I'm going to add 3x. So I've got 6 equals 8x plus 6. When I subtract 6, well, that's a little weird, right? I got x is 0. Well, that's okay. X can be 0. Now we just got to, that actually makes it pretty easy because now I'm just going to take that 0 and back substitute. That's number 4, back substitute. Y is 2 minus 0, so my y is 2. So my solution is the point 0, 2. Okay, so let's talk about when you need to use substitution. Now you can use substitution lots of times, but the easiest is when the variable is alone, or it's almost alone. It was alone in example 3. It was almost alone in example 2. It was almost alone in example 3. All right, let's do one more method, and that's called elimination. This is actually my favorite method. I use this a lot. So some people call it elimination. Other people call it linear combination, and some people just call it the addition method. Just depends on what book they were using when they were taught this method. You'll hear me call it addition method a lot. Okay, so you're going to rewrite both equations in standard form. That's the first step. Well, the example 1 and 2 is already written in standard form. In other words, see the x's are lined up on top of each other, and the y's, then your equals and your number. Just trying to get it organized, okay? So the goal is to get your two numbers, whether it's your x's or your y's, it doesn't matter, get them to be the same, okay? Except one is a plus and one is a minus. So when you add them together, they're going to cancel out. So I could easily turn that 5 into a -10 if I multiplied it by -2. So that's what I'm going to do. I'm going to multiply it by -2. Whatever I do to that 5x, I have to do to every single thing in that. So I'm going to get 10x, I'm going to get -14y, and then I get -12. And then on the bottom, I'm not going to do anything to it. So notice how I note that. I have my arrow, but I don't put anything on it, okay? So then I'm just going to add those together, and when you do, look, those are going to cancel out, which is exactly what we wanted. -17y is equal to 34, and when you divide by -17, you get a -2, which is really nice, instead of getting a fraction. Okay, so we've gotten part of my solution, but I don't have my x value, so I need to get my x value. So I get my x value by doing step number 5, which is to back substitute. So I'm going to pick one of the equations. Guess I'll just pick the top one. Doesn't really matter which one you pick. And I'm going to plug in my -2 right there. So I get 5x plus 7 times my -2. Then I'm just going to solve it for my x. So I'm going to get 5x is 20, so that means my x has got to be 4. So my solution is 4, -2. So when do we want to use elimination? When the variables are not alone, which happens a whole lot. All right, let's do one more, example number 5. I need to make it so that either my x's cancel out or my y's cancel out, and it really doesn't matter which one. So why don't we let the y's cancel out this time, since we did the x's last time. So to get my y's to be the same, I would need to multiply that 2 by what, maybe -3? And that would give me, let's see, let's multiply it by +3. That would give me a +6y, so they would cancel. So that's going to give me, what, -9y plus 6y, -9x, sorry. -9x plus 6y is -30. And then on the bottom, I don't do anything. So I get 9x minus 6y is 30. Uh-oh. When I add those together, my x's and my y's cancel. Oh, and the others cancel. So I get something that says 0 equals 0. Well, that basically means that those are the same lines. Those two are exactly the same. So, so that means, remember when it was the same line, that meant that there's an infinite number of solutions. Okay, because this is the same line. Because 0 will always equal 0. So infinite solutions. Now some teachers like for you to write a solution. If you write a solution, you could write just that line and write all points on that line. You could choose the second one if you wanted. It didn't really matter. Now what happens if when I canceled, I got 0 equals 12 though? I get something that is not true. That just means that it's no solution, because and the reason it's no solution is because it was parallel lines. Okay, but this one I probably shouldn't circle that because that might confuse you guys. This is an alternative. Oop, another problem. Okay, so that's what happens if they cancel out, if this up here cancels out, but you don't get 0 equals 0. You get 0 equals something that 0 is not equal to. That would mean it's no solution. So here's our summary. There's three methods. Graphing, which you're only going to use when you have a calculator. Okay. This one, which you're only going to use when it's easy to get X or Y by itself. And elimination, basically, you're going to use it most of the other times. And you just line them up and then look for matching coefficients. So the very last thing we're going to do is just work several examples. Okay, I've got 4 examples, and then I've got everybody's favorite thing to do, which is word problems. Okay, so let's work some of these. Notice it says solve the system of equations analytically. Okay, so that means you can use any of the methods. I didn't tell you what you had to do. Okay, but notice with this one, it's really easy just to add those because those will already cancel out. Super easy. Um, Now, you could solve it by graphing, you could solve it by substitution as well, but this is the easiest because I can quickly get to that very first answer. So the y is going to be -3, but I'm not finished, right? I've got to go ahead and back substitute. So I just picked the first one. It doesn't really matter. X plus, I'm going to stick my -3 in there now, equals 6. So that means my X has to be 9. So that one was super easy to do. For number 7, okay, now for number 7, graphing, again, we're not going to use. If I wanted to get an X by itself, that would be pretty difficult because notice I've got numbers in front of each of these. Okay, so I would be dividing, it would be sort of a pain. So the best thing is elimination or addition. I just need to get these guys the same. Or you could use, you could solve for, you could get your y's the same. But I'm going to get my x's the same. So I'm going to multiply the top by, let's say, -2. So that's going to give me -6. So that means, and that's -10. So these guys are going to cancel out. 6x plus 4y equals 8. Oh, look, this is one of those again, where when you add them, everything cancels. But notice I get a -2. Okay, well, 0 is not equal to that, and it never will be. So that is a no solution problem. In other words, those are parallel lines. You don't write, I started to write parallel. Don't write parallel. Write no solution. All right. Notice 8 and 9 are a little bit tricky. They have some fractions in them. But that's okay because we know how to get rid of fractions, don't we? So that's my first step. I'm going to multiply that by 5 and that by 5. Those both, each side by 5. And when I do that, I'm going to multiply each piece by 5, and that makes these guys cancel out, which is what I wanted. And I'm going to wind up with x plus 15y equals 155. Okay, that's what I get when I multiply everything by 5. The second one, it just so happens that I'm going to multiply that by 5 also. You don't have to multiply the first equation and the second equation by the same number, but it just happens to work out that way for this one. So when I cancel, my 5's are going to cancel, and I'm going to wind up with 10x minus y equals 40. Okay, now from here, I've got several options, okay? I have a new system of equations. It would be really easy to get one of these by themselves, so I'm going to actually use substitution, but it really doesn't matter. Let me go ahead and write them out right beside each other, one right over the top of the other one, just so that I can make sure that you understand what we're dealing with. Okay, so this is basically what we're starting with. So I'm going to solve this one and make that x is 155 minus 15y. Okay, so I've solved it for x. Now I'm going to take these guys right here and plug it in for my x right there. So so this was step number 1, was to solve it. Step number 2 is to go back in and plug into the other equation. So I'm going to plug my 155 minus 15y. So I'm going to get really big numbers. That's okay. I like big numbers better than I like fractions. Minus y is 40. So now let's simplify a little bit. I'm going to go ahead and subtract that. And then I'm going to combine those. So that gives me 151y is equal to negative 1510. And when I divide, I'm going to get y equals 10. Now, we've done so much work that a lot of students will say, okay, y equals 10, circle it, and we're done. But remember, we need a solution where I have a y and I have an x. So I'm going to plug that back in. I've got lots of choices that I could plug the 10 into, but the easiest one is this one right there. Okay, so I'm going to back substitute into that 155 minus 15y. So x is 155 minus 15 times my 10. So that's what, 155 minus 50? Minus 150. So that should just be 5. So my solution is the point 510. Okay, but it started off nasty because it had fractions. This one's going to start off nasty as well. Ugh, fractions. But that's okay. I'm going to just look at this. What would I need to multiply 5 and 10 by to get them to cancel? That would just be 10, right? If I multiply each piece by 10, I'm going to go through and cancel, which is awesome because I'll get no fractions after that. So that means that very first one is going to turn into 2 times x plus 6 plus 2y minus x equals 10. Whew, so that's my first equation. So let's simplify that a little bit. 2x plus 12 plus 2y minus x equals 10. So x plus 2y plus 12 is 10. So I wound up with that equation. Okay, so that's interesting. Okay, so I have that one. Now let's do the same thing with number 2. Let's work that in a different color. So my second one, I'm going to multiply. I can't multiply by 10 because that won't help me with my 4. So I'm going to multiply both sides by 20. And then I'm going to cancel out. So I'm going to wind up with the second equation. I'll have a 5 times x plus 2 plus 4 times 3x plus 2 equals what, minus 60? Whew! Now I've got to simplify. By the way, this is going to be pretty much as difficult as it's going to get with these. There we go. I'm almost finished. And by finished, I don't mean finished with the problem. I mean finished getting 2 equations that I can actually work with. Okay, so I have my 2 equations. So now I have a choice. I could write them on top of each other and then get rid of my x's if I wanted, or my y's. It doesn't really matter. But because this one is so easy to solve for x, I'm going to go ahead and use substitution. Okay, so I'm going to use substitution. So I would get x equals negative 2 minus 2y. And I'm going to take that and I'm going to plug it in to this one right there. So I'm going to get 15x plus 12y negative 78. And what I'm going to plug in is that minus 2 minus 2y. All right. So we just need to, and as you can tell, this could be really easy to make some careless mistakes. So you have to be pretty careful not to make some boo-boos. So that gives me, what would that give me on that side? Negative 30 minus 12 is what? 18, I think. 30 minus 12. Yep. So negative 18y on this side, and negative 78 plus 30 is going to give me negative 48 on that side. Whew. So now we got to divide. So I get y equals, oops. I must have made a boo-boo somewhere. And like I said, it's really easy to make mistakes. I'm supposed to get 34. Let's see why. 10y. Oh. I had been sitting here working this. Y'all probably knew it and couldn't tell me because you're not face to face. I don't know why I did that, but see that 5y? That 5? That should be a 5 right here. So I would start the video over, but this is a pretty long video. So I'm not. I'm just going to put a 5 right there, and we're going to change this a little bit. Sorry about that. So that's going to give me what? 10 minus 10y plus. There we go. And you know what's funny is I made that mistake as I was saying. It's really easy to make mistakes. It is. Okay. Now let's see. So that gives me 2y is negative, what, 88? So y is negative 40. It's supposed to be negative 34. All right. I need to concentrate. Do you see where I made a boo-boo? Minus 10. Yep. I have another boo-boo. Oh my gosh. When I plugged in, that was supposed to be a negative. I really should start this video over, but I don't want to. All right, there we go. Finally. So here is the good news for you in all of this. If I can make this many mistakes and still have a master's in math, then y'all can make mistakes and still survive. Okay, so my y is negative 34, and then I'm going to plug it back in. Back substitute. So I get negative 2 plus, what's that, 68? So my x should be a 66. So I have my solution is 66 and negative 34. All right, before we do the rest of this section, I think I probably need to stop and drink some caffeine and come back.